Hey guys, welcome back to FPS Zen. So today I have some great information for you on 9900K overclocking. However, it will apply to 9700Ks, 9900KSs, or even the future 10900, 10700Ks that are going to be coming out in the future from Intel. The reason all of this is all related to the same video is because Intel has been on the same architecture since about 2015 with Skylake and has not changed from their 14 nanometer process since like 2014 with Broadwell. So it really hasn't changed much in the past. Really what's become new is the problem's gotten worse with the 9th series now that it has 8 cores. And I just really wanted to dig in on overclocking with these problems, as well as showing you the settings that you might use for your type of overclock, as there are different types of overclock between a fixed frequency and AVX offset and boosting, as well as we're going to get into Windows and we're actually going to stress test this overclock, as well as show you some common gotchas that you might have trouble with a new overclock yourself. Let's not get too far ahead of ourselves. Let's go ahead and get into it. Okay guys, I've gone ahead and booted into BIOS here by hitting delete on boot, and I just wanted to show you some of the settings that I have in BIOS and some of the other settings within BIOS that you may want to use for your overclock. My specific overclock is a fixed frequency overclock. This means that the frequency never changes even for AVX instructions. However, other people may use an AVX offset type of overclock, and there are other types of overclock like turbo boost changes. So I'm going to go ahead and just jump in here. The first menu is the advanced frequency settings under MIT, which is our first tab. Under here we can see I have enhanced multi-core performance disabled. Enhanced multi-core performance generally just takes the highest single core boost for the processor and applies it to all cores. The next thing is the CPU clock ratio. I've set mine for 449, in other words 4.9 gigahertz. And we can also see that from the advanced CPU core settings tab. From the advanced CPU core settings, we can see again the 49 for the 4.9 gigahertz, as well as my AVX offset of 0. And just a quick note on this. So not every overclock is going to get to 4.9 gigahertz, but some overclocks, including my processor, may even be able to go faster than 4.9 gigahertz if I was to use an AVX offset. AVX offset is when the processor gets an AVX instructions or workload. The frequency of the core running that workload is going to be lowered by 100 megahertz per number here. So this would be 100 megahertz, 200 megahertz, 300 megahertz, etc. Why you would want to do this is AVX instructions take more power and produce more heat. So in order to make the AVX instructions put out as much power and heat as a normal instruction, it has to slow down the processor to do so. However, I actually use AVX instructions as I edit videos like this one here, and other people may also use AVX instructions for other professional type workloads. For people like me, they may want to still use an AVX offset to keep that power draw and temperature in line with the normal instructions, or some people, like myself, may want to run an AVX offset of 0 and actually overclock for AVX. Overclocking for this type of workload allows me to run my maximum overclock while actually using the instruction set I want. The next thing I want to make a note of is the TJ max temperature. This is set for 110 degrees Celsius. The next thing to note is I have Intel's turbo boost technology disabled. Again, I'm not using a boost overclock here, so I want to disable any type of frequency changing or boosting going on. Heading all the way to the bottom here. The next thing I want to note is that I've disabled the Intel speed shift technology, the ring to core offset downbend, the CPU EIST function, the race to halt, the energy efficient turbo, and voltage optimization. All of these are to save power, however, may be at the cost of stability. So I've gone ahead and disabled those. Same thing for the C states on the processor. I don't want it changing states or slowing down or halting. So we have disabled C1E, C3, C6 and C7, C8 and C10, and set the package C state limit to C0, C1. Jumping back out of the advanced CPU core settings, we can also see that I have my memory running its XMP profile 1. My memory is 3200 CL14, and this profile loads that up without having to set anything else. Next thing to look at is back out to the MIT menu, advanced voltage settings, advanced power settings, and we can now see our vCore load line calibration. Load line calibration increases voltage while there is a load that pulls down that voltage. So setting it to turbo here actually increases the voltage under load. The next thing to take a look at is CPU core voltage control menu. And here we can see CPU vCore. I have mine set for 1.4 volts. Now, a lot of people think that 1.4 volts, while it is the maximum voltage for a Intel 9th Gen processor, setting it here to 1.4 volts is not bad, because this is actually going to be the voltage that the VRM is going to try to put out to the processor. That's not actually what's going to make it to the processor, so it's actually going to be lower, and we'll see that within hardware info once we get into Windows. Okay guys, I'm here in Windows and I'm going to go ahead and open up a piece of software called Hardware Info 64, which actually reads the sensor information off your motherboard and other components and actually outputs them to where you can see those values for, say, frequencies, temperatures, voltages, etc. This is very important information, especially if you're doing an overclock, so you can see what the hardware is running at. This is a free piece of software. You can just go out to the web, download it, and install it, and get this information off of your hardware. Once we have it open, I'm going to go ahead and go over a few of the basics within the software, though there is lots of different information you can glean from here. The first is going to be our Core 0 clock through Core 7 clock. This is the actual frequency of the cores. We can see here that I have a 4.9 gigahertz overclock, and it's a fixed frequency as it's not dropping on the minimum here, so it's never slowing down. The next thing to take a look at, as far as basics are concerned, of course, is going to be our Core 0 through Core 7. And that's actually going to be the temperature for each of the cores. We can also see a CPU package or overall temperature, as well as a maximum, so whichever core is the hottest will show here. Once we know where our temperatures are, we can continue on. The next bits here and here are going to be all our performance limiting or slowdown reasons. For whatever reason, we hit an over temperature situation, something like this would flag to yes to let us know that it did have to slow down the processor due to the heat or voltage, etc. The next thing that we can see from here is our memory. We can see that my memory is set to 3200 since it's double data rate of 1600 here. And we can also see the TCAS here, or CL is another way to say that, and this is CL14 RAM, so we can see that my memory is set for CL14 3200 from here. This is just confirming that that XMP profile we loaded in BIOS is working correctly. The next thing to take a look at is going to be here, the VRM MOS. The VRM MOS, at least again, this is just on my Gigabyte motherboard. The sensors on a different brand or model motherboard may be different. However, the VRM MOS is going to be the temperature of the VRM being the voltage regulation. The voltage regulation here is important because the temperature on the voltage regulation may overheat before the processor overheats. And if it does, you'll still be getting a performance limiting reason. So we definitely want to make sure that this stays cool as well. A popular situation where this might get too hot is if you bought, say, an Intel Z370 motherboard, which was made for up to a 6-core processor, or designed, and you upgraded to, say, a 9700K or 9900K, and the motherboard may not have been a good enough voltage regulation to handle the voltage it would need to handle, say, a 9900K. So this is definitely something important that we'll have to take a look at today while doing some of our stress testing. The next thing to take a look at, we're going to go ahead and scroll down a little bit here, is our VRV out. So as I showed you in BIOS, my voltage is set for 1.4 volts or vCore, and we can see here that 1.4 volts is not making it to the processor. We can see currently it's 1.383 volts is making it to the processor, and probably even a little bit lower than that since this is just the closest sensor to the processor. So just so you can see here, it is not a full 1.4 volts, which is the maximum safe for the 9900K and the 9700K processors. Continuing on here, we can also see my RAM temperatures, which is only about 27, 28 degrees Celsius, so not hot at all, and not something that I particularly need to take a look at. But if you were to do a manual memory overclock or something like that, you would likely want to be keeping an eye on those temperatures. And that's all we'll take a look at for right now. That just gets us the basics, and so I'm going to go ahead and return to the top here, and we're going to start with doing what I would do as far as a Prime 95 stress test. So I'm going to go ahead and open up the latest version of Prime 95 here. I've actually made 3 separate copies of it with 3 different named folders here on my desktop, as I like to stress test with different instruction sets all at the same time. We can see here the number of torture test threads to run. My 9700K is not hyper-threading, so it only has 8 threads, 8 cores. And due to that, I do not have to double this number, but if you had a 9900K, you may have to double the number that I input here for torture test threads to run. The first one that I run, I only run at 4 threads. So 9900K, you'd be running that at 8 threads. I want to run half the threads of the processor, running a SSE or normal workload. Now, a lot of people like to come in here and select smallest FFTs or small FFTs, and what that's going to do is actually on an interval set by the programming here, which you can see down below, even though it's grayed out. It's going to run a FFT size of 41 to 256. It's going to run them in place, and it's going to run each of them for 3 minutes. So what's going to happen is maybe for the first 3 minutes, you'll have a light workload. The next 3 minutes may be a heavy workload. The next 3 minutes after that may be a CPU bug type workload. And what I mean by that is this Prime 95 application is kind of bugging out the processor to generate ridiculous amounts of heat that you would never see in a real workload. So we need to be careful with this software, since if we were to run smallest or small FFTs, it's going to perhaps run some workloads that would be unfavorable, and really we'd be testing for a scenario that wouldn't really ever happen, and you may have to detune your overclock due to that to make that stable, when again you're never really going to have that type of workload, so you'd be lowering your overclock for no good reason. So when I am using Prime 95 for stress testing, and I'm not saying to not use it, I come down here to custom. Minimum FFT size, we're going to use 1344, maximum 1344. This is actually setting a fixed FFT size, so that way we know exactly what we're testing. This is a real good FFT size for testing overclocks, and I generally don't use any other FFT size, though there is a few other good ones to hit. So we're going to run it in place, and 3 minutes is fine. 5 minutes is also a good one as well. Since this is my first one where I'm going to run half the processor, I'm going to disable AVX2 and AVX instructions. These are those instructions I was referring to in BIOS, where the processor might detune or slow down to be able to process them as they generate more heat on Intel processors. I'm going to go ahead and get this thread started here. I'm going to go ahead and open up my second copy, and we're going to do 2 threads this time. Again, on the 9900K or 1090K, you're going to be running that at 4. Custom, 1344 again. Fixed size here. We're running them in place. 3 minutes is still fine, and I'm just going to disable the AVX2 this time. So this is going to be 2 threads of AVX instructions. Go ahead and starting that up. And then the last one here, I'm going to go ahead and boot up. And for this one, we would normally run on the remaining 2 threads. So 4, 2, and 2 is 8. And we'd run it custom. We're going to run the 1344 again. In place 3 minutes, and we're going to not check the AVX2 box. This means that the stress test is going to run these last remaining 2 on AVX2 instructions. However, In this use case where I'm recording, I do not want to overstress the processor, but I do want to show you how you would do it on yours. Since I am recording, I don't want to, say, have too many drop frames, etc., as the processor at this point would have a lot of trouble keeping up. So I'm going to go ahead and cancel out here. But normally this one would be running. Then the next things we're going to do is go ahead and just jump right back over to the hardware info 64. And we're going to take a look to make sure the processor isn't changing in frequency. Again, we have a fixed frequency overclock, so any changes there would be things that you would need to fix. And next, we want to take a look at the temperatures. And we can see that the temperatures have definitely gone up since we first started up the program. The program saw a minimum of 20 degrees Celsius here. And you can see now they're up in the 70s or 80s. Just depends on the core. And if we come down here to package, we can see the whole package itself was in the 20s and now it's in the 80s. And then again, our maximum core temperature was in the 20s and now in the 80s. We can also see here that there is no thermal throttling currently. Down here we see again no thermal throttling. I wouldn't expect the memory to change, but the memory still looks good. And then we're checking that VRM temperature. The VRM temperature was in the 10s and now is in the 40s. So we can see that this Gigabyte RS Pro Wi-Fi motherboard is actually running extremely cool. In fact, most of the Z390 Gigabyte motherboards have very, very good VRMs. So the temperatures on all of those should be pretty low as long as you got above the base model. But if, for example, you had, say, a Z370 and you were running this 9700K on that, you would likely be running in the 80s and likely getting closer, especially if I was running all of the primes, including the last one. You'd likely see the temperatures go even higher, and with those higher temperatures, you'd probably be seeing the Z370 hit 90s and therefore start thermal throttling the processor due to the VRM not being able to handle the juice. But since we're on a Z390, you know, that was kind of designed to match the 9700K, 9900K with the higher voltage pull, and therefore has a better VRM on it, and therefore keeps the temperatures cooler. Going ahead and scrolling down, I want to check on my VRM output. And make sure that that voltage is not hitting 1.4 volts, which is the maximum safe for the processor. And we can see here, now that there is a load, it's actually lower. We can see that the processor did hit a maximum of 1.383 volts, which is kind of the maximum while it's sitting there idle. And now that there is a load, the load actually lowers the voltage going through. So you can see that it's only running approximately 1.347. So it's going to be lower now that there's load on it. So not huge concern, as we know that this is going to be lower and it was already good while sitting idle. But I do like to check this to make sure there isn't any crazy LLCs or load line calibration settings that are causing the voltage to spike for some reason. Spikes above 1.4 would be something that I would consider unsafe, and I'd want to immediately shut down, go find out what caused that, and get that fixed before continuing. And then of course my RAM, now that it's being used, has gained in temperature. It's in the 30s now, but nowhere near concern. Okay, and that kind of shows you what a good Prime 95 run would look like, as well as I'm going to continue on and show you kind of what Blender benchmark and maybe some other stress tests that I would run to verify an overclock. However, I wanted to show you some bad results too. And this is an already verified overclock. You know, it's going to stay within temperature on all the workloads that I stress test for. It's going to not overvolt, go past that 1.4 maximum V-core that I would want going into the processor, etc. However, what I see online is people asking if their overclock is okay. They're having some trouble. Maybe the temperature's going too high due to maybe the voltage going too high, or maybe their voltage is too low and they're seeing freezing, crashing, and rebooting of their computer. And Something that before I even start to go and change the settings on the hardware, I want to make sure that they're stress testing correctly, because if you're stress testing for a workload that you are not expecting to ever have your computer run, you're kind of perhaps down clocking or overvolting for no reason. So I'm going to go ahead and just show you one of those scenarios real quick here, and we have already touched base on this, but I'm going to go ahead and boot up Prime 95. I'm going to have it run on all the cores this time on small FFTs, and I'm going to leave it set to AVX2, so it's going to generate as much heat as possible. And what we're going to see here is right now we're running at about 40 degrees Celsius. I hit OK. We're already in the 50s and now hundreds, 90s and hundreds, you see here. And I can go ahead and just stop or exit Prime 95 at this point, as it's already hitting errors. This is a workload that I would never expect to run on my processor, and due to its power bug type workload that it's putting through the processor, it's generating a lot of excessive heat. And due to that excessive heat, you're starting to see 108 degrees Celsius, etc. here. And if it was able to run any longer without errors, it would likely be even higher in temperature. And this is what a lot of people see when they go to run Prime 95. They might run Prime 95 and have it run okay for 10-15 minutes, and then suddenly it changes FFT size, or the workload going through, and that workload could suddenly jump to one of these kind of workloads, and suddenly their temperatures are spiking. So you might have normal temperature for 15 minutes, no problem, and then suddenly, bam, you're in the hundreds of degrees Celsius. So the workload that Prime 95 is running is really of the utmost importance in verifying your overclock. You don't want to run just any workload. You want to make sure that you're running a specific workload that you know you're going to be running on your processor, or just go ahead and use my recommendation of the 1344 FFT size for when you're using Prime 95. Of course, Prime 95 is not going to be the end goal here, though. Prime 95 is a good place to start, as well as making sure that the math going through the processor is good. Otherwise, you'll get those fatals that you saw just a moment ago. But we definitely want to do the other benchmarks as well to make sure that things like Blender with AVX instructions is going to be okay for an extended run, etc. So I'm going to go ahead and continue with Blender benchmark now. Okay guys, so I'm going to go ahead and open up Blender benchmark. And Blender is a AVX instruction stress test. And this is an extended stress test. This is going to take maybe about 30 minutes. And we want to make sure it's set for the CPU, and we're going to run the quick benchmark. This is actually going to run 2 renders in Blender in the background. While it runs, we're going to be looking at the exact same stuff that you would look at during a Prime 95 stress test within hardware info. Okay, now that Blender benchmark has ran for a little while, I've went ahead and canceled out of it, and we're going to go ahead and take a look at the information that we can find from hardware info after this stress test. We can see that the frequency of 4.9 gigahertz is not changed at all, so no downclocking. The temperatures on the cores, we can see, got up to 96 degrees Celsius, which is fine for a 9th gen Intel processor. In fact, if we look here at the Core 0 through Core 7 distance to TJ max, which is the maximum temperature the processor should be able to go up to before it starts thermal throttling, we can see on each of these cores it was 18 degrees Celsius away on this one, 14 degrees Celsius away on this one, so we still had about 14 degrees Celsius headroom before any thermal throttling. We can see the package and the highest core got to 96 degrees Celsius. So that's just fine on a 9th gen Intel processor. We already know from the TJ Max that we still had plenty of headroom, so there shouldn't have been any thermal throttling, but we can see in this section here there was none, as well as in this section, no thermal throttling. Again, the memory should never change, but we can see the memory still at a good state here. We're going to take a look at the VRM next. So the VRM got up to 56 degrees Celsius, which is not bad at all. Again, since this is a Z390 motherboard by Gigabyte, they have great VRMs on these motherboards, so I wasn't expecting the temperature to get anywhere close to 95. So this VRM did great. The next thing to take a look at is that VRV out, and we can see again, due to it being under load, we never go higher than when it's sitting here at idle, and idle is 1.383 volts. So that is what's going into the processor as far as voltage to keep that frequency stable. And lastly, the RAM got up to approximately 37 degrees Celsius here, but that's nowhere near thermal throttling for memory either. So everything is looking great as far as Blender benchmark stress test on this processor. I already knew this since this overclock is already been validated, but this is what you would do or kind of check when running Blender benchmark to test stability and temperatures. Okay, and the last stress test of the day is going to be the X264 stability test version 2. Once it's unzipped or extracted, we're going to open it up and launch the .bat. Give it a name. It's going to ask how many loops you want it to run. I want it to run until I want to close it. So I'm going to type infinity and hit enter. It wants to know how many threads you want it to run. I have an 8-thread processor, so I'm going to run 8, but I could run, say, double, say 16, and try to get a little bit more load on there. But I want this to be a realistic workload. So I'm going to use 8, and normal for the priority. It is now running on all 8 cores. We can also see this reflected in hardware info here, where core usage is approximately about 95% used. This is a more realistic stress test, as no real program is going to be hitting your cores at 100% CPU usage at all times like Prime 95. Again, that's why we use other stress tests other than Prime 95 for stress testing mostly, such as Blender Benchmark and X264 stress test, as it's not really a CPU bug or temperature bug type benchmark or stress test. The next thing to take a look at here, other than the processor is not downclocking, again due to my AVX0 setting, is the temperatures. And as we can see here, the temperatures are in line with what I would expect on this type of stress test or workload. And we are a good ways away from that TJ max, or maximum temperature, where we're going to start thermal throttling. Again, no thermal throttling situation going on here, as well as here. The VRM is only 45 degrees Celsius, which is far from what I would expect to be the maximum of 95 degrees Celsius. And our voltage is 1.347 volts. So again, due to the workload, the voltage is going to be lower than what it is at idle. So we're in a good situation right now. Now, of course, this did just start running. You would likely want to run your X264 stress test for an extended period of time, say hours, to verify that your, say, liquid cooling loop has reached its maximum temperature, or even in the case of air cooling like my Dark Rock Pro 4, I want to make sure that it reaches its maximum temperature before we go ahead and assess that this overclock is remaining within temperature and voltage. I'm going to go ahead and close out here by hitting Control C and then Y and enter. That'll stop the test. As we can see here, our core usage has dropped to below 10%. Okay, now that we've seen all of our stress tests that we do expect to running correctly, I wanted to actually talk about the situations that you would run into during overclocking that we need to actually correct for. So the first thing that I want to talk about is if your computer freezes up, reboots, or crashes. And that could be even application crashing, or for example in Prime 95 it'll actually show you fatal error when one of its workloads crashes. And any of that means that either the frequency is too high or the voltage is too low. In my situation, my voltage is set really high at 1.4 volt V-core, as well as an LLC of turbo. I guess there is a tiny bit more headroom there where we could up our voltage here at VR out a little bit more, but we are really, really close. I probably wouldn't go any further. But if you were, say, in this situation where you're already maxing out on the voltage, we would have to pull back on the frequency or use something like an AVX offset, where the AVX or higher temperature outputting instructions would be lowered to a lower frequency individually. Keep in mind though, running an AVX offset can increase instability, so that's something to keep in mind. Just depends on your goals as far as your overclock. Mine was to run an AVX offset of 0 for the type of workloads that I run on my PC, which are AVX workloads. So I definitely want those workloads to run at a fast frequency, so I wanted an AVX 0 offset. But you could definitely run an offset if you're not running AVX instructions and still keep your SSE or normal workloads running quickly on a higher frequency without having to take that frequency down like I did to 4.9. You might be able to run something a little higher like 5 or 5.1 gigahertz using an AVX offset. The next thing that I want to talk about is your PC is staying up. So it's staying stable, but the next thing that likely happens if you stay stable is your temperatures they are running into hundreds of degrees Celsius, especially on a 9th gen Intel processor. The thing that you really want to be taking a look at is voltage. A lot of times people are setting up their overclocks by setting a frequency but not setting their V-core or LLC and letting the motherboard just have its auto setting. The auto setting on the motherboard really does not know what the optimal voltage setting for your processor is, and it usually overvolts it to remain as stable as possible. The problem with that is it might exceed the 1.4 volts stable for the processor, which can cause processor degradation or causing it to require more voltage or lower frequencies over time, as well as it might not be. You know, if we look at our VR V out, the auto setting may be in line. You may not be hitting 1.4 volts, but maybe your cooling isn't good enough to keep the CPU under temperature. So definitely something else to keep a look at. My build specifically is using the Dark Rock Pro 4 air cooler, and it's keeping a 9700K under these settings cool. However, there are lots of liquid and air coolers that may not be able to handle certain settings on the processor. Certain processors run hotter than others, might require more or less voltage than others, etc. So that's where the overclocking comes in. You're kind of finding out where your individual sample sits within the silicon lottery. Okay guys, that's pretty much it. If you have any questions or have anything that you'd like to run past me, please go ahead and throw it in the comments and I'll get back to you. And if you liked today's video, go ahead and like, subscribe, ring the bell, do all those YouTube things, and we'll see you in the next one.